Welcome to the second lesson in Session 5 on sequences. A sequence is a list of things, which are usually numbers, that are in some type of specific order. For example, 3, 5, 7, 9, followed by 3 dots is a common sequence. The order is important here, so each term is assigned a value. So 3 represents the first term, 5 represents the second term, 7 represents the third term, and 9 represents the fourth term. The 3 dots indicate that the sequence continues on infinitely without end. If a sequence goes on forever, it's considered an infinite sequence. Otherwise, if it has an end and there's a limited number of elements in a sequence, it's referred to as a finite sequence. So for example, we have 1, 2, 3, 4 with 3 dots. That represents an infinite sequence of counting numbers. 15, 10, 5, 0, and -5. Also an infinite sequence, beginning with 15 and decreasing the previous term by 5. So notice we're providing a description for each sequence. Here we have a finite sequence representing the multiples of I. We have I, -1, -I, and 1. And next we have a sequence that's also finite, goes 64, 32, 16, 8, 4, 2, and 1. And this sequence begins with 64 and divides the previous term by 2. Now each sequences have rules. Now the descriptions that we provided earlier are okay, but we need to be much more specific. So many sequences have a rule, and this is a way to find the value of terms that are not provided. So saying a sequence starts at 3 and skips 2 every time is a start, but it won't help us find the 10th term or the 100th term or the nth term. Now the n represents a variable term. It could be the 100th term, the 1000th term, or the 1,000,000th term. So we're going to use a table here to identify what the nth term is, and that's going to provide us a formula which will allow me to identify any term we choose. So let's correspond the value of the term with the number in the order of the term. So the first term is 3, the second term is 5, the third term is 7, the fourth term is 9. So using this information, we can produce the nth term formula. And the nth term formula allows us to find any term in the sequence. In this case, if we put the term and represent it as n, then its corresponding value would give us 2n plus 1. So that 2n plus 1 is considered the nth term formula. Once we have the nth term formula, I can find things like the 10th term by plugging in 10 for n, giving me 21. I can also find the 100th term in the sequence by plugging in 100 for n, giving me 201. There's 2 types of sequences that we're going to learn about. First is the arithmetic sequence. An arithmetic sequence is a sequence where the difference between one term and the next is a constant. For example, 1, 3, 4, 7, 10, 13, 16, and so on is an arithmetic sequence because one number to the next is found through adding or subtracting. In this case, we would add 3 to each term. So there's a common difference of 3. We're able to find the nth term formula for an arithmetic sequence using the following formula. X sub n is equal to a plus d times the quantity of n minus 1, where a represents the first term in the sequence and d represents the common difference. So first thing we're going to do here is find the nth term formula for the previous sequence. I need to know the first term, which is 1, and I need to know the common difference, which is 3. So I plug those values in for a and d in my formula, and that gives me 1 plus 3 times the quantity of n minus 1. From there, we're going to distribute and combine like terms, and I get an nth term formula of 3n minus 2. Now this is going to allow me to answer the follow-up question, which is now that I know the nth term formula, let's find the 37th term in this sequence. So to find the 37th term, I just plug in 37 for n, multiply and simplify, and we get a value of 109. So the 37th term in the previous sequence would be 109. And we're allowed to identify that by identifying what the nth term formula is. Next, we're going to learn about a geometric sequence. In a geometric sequence, each term is found by multiplying the previous term by a constant. So for example, we have the sequence 2, 4, 8, 16, 32, 64, and that continues on infinitely. In this case, if you take the previous term and multiply it by 2, you will produce the subsequent term. So this is a geometric sequence that has a common ratio of 2 because you multiply each term by 2. Now we're able to find the nth term formula for a geometric sequence using the following formula. X sub n is equal to a times r to the n minus 1 power, where a represents the first term in the sequence and r represents the common ratio. So for example, we're asked to find the nth term formula for the previous sequence. So remember, the two pieces of information that we need are the first term and the common ratio. And in this case, the first term and the common ratio are both 2. So we input them into the formula, and we get x sub n is equal to 2 times the quantity of 2 to the n minus 1 power. No need to simplify here. We can leave this as is, and that represents our nth term formula. Now we wrap this lesson up by identifying the 12th term for the previous sequence. So if I substitute 12 in for n in my nth term formula, that's going to allow me to identify what the 12th term is. So we simplify. 12 minus 1 is 11, 2 to the 11th power, and then we multiply that value by 2, gives us 4,096. So the 12th term in the previous sequence was 4,096. So that wraps up this lesson on sequences. Feel free to email us if you have any questions. Good luck on the quiz.